So hello viewers, and in this video we are going to see that how we can use Cisco Packet Tracer to simulate and observe the BGP protocol. So we are going to configure a BGP protocol between two devices, and we are going to see that how we can observe the BGP packets that are there while we form in the BGP membership. So yeah, without wasting much time, let's get started. So as we had an very good comment or feedback in last OSPF video that we have made with the Cisco Packet Tracer. So with the BGP we are going to take a very slow step, since BGP is very big protocol and there are lots of things to cover. So in this video we are going to just take two devices. So from routers, from networking devices, from routers, we are going to take this 1841 router. So we are going to take two of this router, and then we are going to connect, and from these connections we are going to select this automatic connection, and we are going to connect this router 1 and router 2. So this is our basic topology. Let's just first name them. So first let's say what will be the IP address. So we are going to take 192.168.10.0/30. that will be the IP address or the network subnet mask. So IP subnet mask that we are going to take between these two devices. So 10.1 over here and 10.2 over here. Now let's just look at what is the interface. So both has fast Ethernet FA0/0, and this will be 192.168.10.1/30, and over here this is also FA0/0 and 192.168.10.2/30. Now this is not necessary, but this is just for us to have an idea without needing to every time go and watch the show IP interface command, or either go to GUI of this router and observe what are the IP addresses. So this is just for us to understand and grab a basic understanding very easily. Now that we have an idea about our topology, let's just assign the IP addresses first. So to assign the IP addresses, we have two ways. Either we go to CLI of the devices, or we use the GUI configuration that we get from the Cisco Packet Tracer. Remember, this GUI that you are seeing over here, that we don't get usually for the networking devices. We will have an access, we will have always an CLI. We won't have any access of GUI for any network devices for us to configure, right? So let's just first go through how we can use the GUI, then we will also have an overview of how we can assign the IP addresses using CLI. So first, if you want to go with the GUI, you can go to this config section, and here you will have interfaces. Under interfaces you will have fast Ethernet 0/0 and 0/1. As you can see, we are inside router 0. As you can see this label over here, and we will have to assign as according to our naming conventions, or the IP address assignment that we had over here on the label. So we will go to fast Ethernet 0/0. You can confirm the label over here. Now what we are going to do is we are going to assign the IP address 192.168.10.1. Now with the subnet mask, as we have /30, so we will need to choose the subnet mask, put the subnet mask accordingly. So /30 means all the first three all the first three bytes are all 1, so that means 255.255.250y, and the last is first 6 bits are 1, so that is equivalent to 252. Now we are going to make sure that port status is set to on. So that's how basically you can use this GUI to configure the IP addresses over here. And you can also see the equivalent iOS command over here for whatever things that we have did over here. Now you don't need to see this, but now we will have an overview about how we can use this CLI to configure the same. But now that we will observe from this router 1. So let's just do that. So now we will again have to click on this router 1. So once we click on this router 1, we will have this Now we will need to go to so first, if we want to go to GUI configuration, so we went for this config. Now for the CLI we will go to CLI. So this is just as simple. Now what we are going to do is we will go to this terminal, and the font size, I don't know how to make the fonts bigger, because it is not visually appealing for me, also not clearly visible because the fonts are very smaller. You can make, if you know how to make this font bigger, you can just have a comment down below the video, so that the people who are watching this video, they can also know. I'll also pin this comment if anyone knows that better. I haven't gone through on the internet to search it out actually. So now move on to the topic. For us to configure, we will need to go to global configuration mode. For that, we first need to fire enable command, then configure terminal. The shorthand for this is conf space t. Now interface fa0/0. So that's basically the interface fastness 0/0 that we want to configure. Now we want to configure the IP address. So IP address, then 192.168.10.2, and the subnet mask, which is 255.255.252, which means /30. Now we will need to bring this interface up. So for that, we will need to enter no shut. And now, as you can see, it says the state for this interface set to state 2 up. Now we can go and press this or enter this end command, so that can use this show IP interface brief command, so that you will see that we have fast Ethernet 0/0 assigned with this particular IP address, and fast Ethernet 0/1 which is not yet assigned any IP address. So that's it, that's we want. And for us to simulate BGP, first what we are going to do is we'll go to global configuration mode, and for us to see that whether the routes are getting changed or getting exchanged or not, instead of having, or other than having this directly connected interface, we are going to configure a loopback. So let's just create interface loopback 0, IP address 10.10.10.2, then 255.255.255. So basically /32. That's the usual IP that we assigned /32 for all the loopbacks. Now we will bring this loopback up. For that, we will use no shut. Now we will use the conf or the exit command to go back to global configuration mode. So yeah, that's how you use this CLI to configure these interfaces. And as you can see, both the triangles are now in the green state. That means both are successfully discovered the neighbor devices with the CDP protocol, Cisco discovery protocol. So that successfully we configure. And again, to configure that, to verify that both the devices are actually configured or connected or not, what we can do is we can go to either of these devices. So we are currently on router 0 from the global configuration mode. So from the global configuration mode, conf t. So what we can do is we can ping 192.168.10.2. So that's basically the IP address, the directly connected interface of this router 1. Now we can check. Oh, okay. So we need to go back to this mode, ping 192.168.10.2. So as you can see, it says 80% pass, but from subsequent ping it will say 100% pass. So that's verification that both of the routers are connected and our IP addresses, IP assignment is successful. So that's the completion of step number 1 that you need to have for your BGP. And yeah, before we actually configure the BGP on router 0, also we will configure an loopback. So from global configuration mode, we are going to go for loopback 0, interface loopback 0, and then IP address 10.10.10.1. So then the subnet mask 255.250. 255.255.255. Then no shut to bring this loopback 0 up. Then we will go back to global configuration mode, and one more mode back, and then show IP interface is brief. So yeah, we can see loopback 0 and fastnet 0/0 both are configured and up over here. So that's the basic thing that we will going to need. Now what we are going to do is we are going to configure an eBGP session between these two devices, because IGP is not supported for the Cisco Packet Tracer, and that's why we will need to use an eBGP between these two devices. So we will configure eBGP between these two devices, and we'll see that whether the loopbacks are exchanged between these two devices or not. So yeah, that's how we will verify and configure the BGP. So yeah, before we start configuring BGP, first let's apply some labels just for the understanding. So ASN, so as we know that we need an ASN, so 65001, so that's the ASN that we will use for this router 0. And as we are going to configure the eBGP, because the iBGP is not supported, so here for router 1 we will keep the ASN 65002. So yeah, that's the values that we are going to move forward with, ASN 65001 and 65002. So now let's configure router 0 first. So for the router 0, we will need to go to global configuration mode. And now once you are in the global configuration mode, what we need to do is we need to enable the BGP process. For that we will need to use this command, which is called router BGP. After that we need to specify the ASN number. So let's just take 65001. Now after that, the first thing that we must do, which is to provide this BGP router ID. So BGP router ID. So usually the router ID is, if we don't provide any, so that is the highest number of IP address interface. So that will be by default chosen as the router ID. But if we are going to assign it manually, what we need to do is we usually assign the IP address of the loopback 0 for any of the router ID of any of the routing process, whether it's OSPF or BGP. So over here we are going to do the same. So for loopback 0 we have this IP address 10.10.10.1. So over here we will assign this ID 10.10.10.1. We can give any number, that doesn't matter. Just for the sake of simplicity, we are moving forward with the loopback 0. Now we need to configure the neighbor. So for this we will need to use this command, which is called neighbor. Now we need to specify the IP address of this neighbor. So how we are going to, what is the IP address that is reachable? So for that we need to make sure that whatever the neighbor that we are entering over here, that should be reachable from this router 0. That means that IP address should be there in the routing table of this router 0. As you can see, we have this directly connected interfaces, so that verifies that we will have this 192.168.10.2 in the routing table of this router 0. So we don't need to worry about the right now, because we just have two devices. Now what we need to do is neighbor, then the IP address 192.168.10.2. that is the router 0's IP address and directly connected via fast Ethernet 0/0. Now we need to give the remote AS number. So remote AS, so that is the ASN number through which this router 0 is reachable. So 65002, that is the neighbor's ASN number. Now that is the literally configuration that we will need. But here we want to redistribute this loopback 0 also in our routing updates. So that is only possible if we write the command redistribute connected. So that means whatever the interfaces are connected, please redistribute for me for or from the BGP update. So that's the meaning for this. That's the literal meaning for this redistribute connected command. Now we can go back to global configuration mode, or the one mode below the global configuration mode, user executable mode. Now from router 1 we will literally do the same configuration. So from the global configuration, we are already in the global configuration, we'll enable the BGP routing router ID routing process, so provided with the ASN number. So for this we are going to take an ASN number 65002. Now we need to provide the router ID, so BGP router ID, then 65 sorry, not 65, 10 10 10 2. That is basically the loopback 0 IP address over here that we have assigned for the router 1. Now we will configure the neighbor, so 192.168.10.1 and the remote AS 65001. So that's basically this device 192.168.10.1 with the ASN number 65001. Now we will need to write this redistribute connect command to advertise this loopback 0 from the BGP packets or the BGP updates. So that's the command, and now we can go back to global configuration mode and then the user executable mode. Now we can issue this command which is called show IP route. So as you can see, we are learning this B. So B means, if you can see over here, B means BGP, and if you see, we are learning 10.10.10.1, which is the loopback 0 address of this router 0, and that is reachable via 192.168.10.1. that is basically this directly connected interface fast Ethernet 0/0, and two networks are directly connected, so that's why we have this C connected over here. And now we can verify the neighborship, or we can see what are the neighbors that are there for my BGP configuration through this command, which is show BGP or show IP BGP summary. So that will list all the neighbors that we have, and we need to make sure that we have the state established, or this up and up down should be properly configured, this neighbor and this stuff. This should be properly configured. There is also one more command with this, which is show IP BGP neighbors. So that is the very brief command. So that will have all the summary of what are the neighbors, what are the route that has been exchanged, and few more details if you want to explore this command. The same command we can explore and see over here or on router 0. So from user executable mode, show IP interface brief. So you can see we have fast Ethernet 0/0 assigned with this IP address loopback 0. Now we can see show IP route command to see that we are receiving this route 10.10.10.2 via 192.168.10.2, which is nothing but this router's one's loopback 0. We can also see the neighbors using show IP BGP summary. We can also see the detailed neighbors command using show IP BGP neighbors. So these are the show commands that you might need to debug. And if you want to see the packets that are there exchanged, that we have also seen in the last session of the BGP, so what you need to do is you need to go to simulate mode, and you will need to play this press this play button, and before actually you configure the BGP, so that you will observe all the packets, so TCP handshakes and all the stuff that we have seen in the earlier video, all the packet captures that you can observe over here. So I think that's it for this video. I hope you have got the idea about how we can configure two devices inside Cisco Packet Tracer, and we can simulate the BGP protocol, and how we can observe BGP packets. So with this video, I guess that's it. We will in the next video we will explore more about BGP in the Cisco Packet Tracer. So we will take more devices, and we will see that how we can configure the Cisco Packet how we can configure the BGP inside Cisco Packet Tracer. So that's it for this video. I hope you have liked it, And if you have any comments, please feel free to post your comments in the comment section, and we'll meet in the next video. Till then, keep learning and keep exploring.